Okay, folks, thanks for trusting us again. Coming back, please like and subscribe, and let's continue. I want to introduce a very small concept. We are still doing the Delta PLC. We are still doing programming, so we are looking at I want to look at the basic concept of interlocking. All right, there is a mechanical interlock, which is physical, which is what called this hardware. Mechanical interlock is hardware that you put between two conductors mostly, all right, or what call this, or relays that does not allow them to engage at the same time, all right. Does not allow them to engage at the same time. So it's like a seesaw. It's, you know, like if you are sitting on a seesaw, if one side is up, that one has to be, if one side is down, that one has to be up, and vice versa, all right. So they can't both be what? They can't both be down. So what it basically does is, remember, a conductor has to go in. So if a conductor is if you place a mechanical interlock between two conductors, what it basically means is if the one conductor goes in, the other one is locked out, and vice versa. All right. So now what I'll look at, however, is the electrical interlock, because we're doing programming, so therefore we can't program physical. We can only program software. All right. So what I'll do is we'll program an electrical interlock. I want the concept of interlocking to be very I call this to be simple and straightforward to be understood. Now let's open. Okay, I happen to have been doing this. Let's just start a new program. Yes, we want a new program. Yes. Now, what you want to call it is basically interlocking. All right, interlock. All right. So the interlock, we are going to use our PLC is the SST. All right, and then we want to say this is the Delta PLC WPLSoft interlock. So I want to name my file. All right, then I will say okay. Now the concept is basically what we want. Let's look at where an interlock would work. For instance, if we want, there's two processes that cannot happen at the same time. Then if those processes are controlled by what? By our conductors, we can then program or wire, even mechanically with a mechanical interlock. It's good practice to use both. All right, for security purposes, it's best practice to use both a mechanical and the what? And the electrical interlocking, but we are today looking only at the electrical aspect of it. We're going to look at the practical one, at the mechanical one when you look at the practical. All right. So now let's expand our programming mode panel there, and then what I want to do is let's remember the direct online. Remember, direct online is simply about start, stop, start. Let's think of a remote control gate. Let's think of a gate. A gate is either standing still or it's moving in the one direction or the other. All right, it's either closing or opening. Let's think of a lift. A lift is either moving up or moving down or still. All right, so there's where we cannot allow the motor of a thing. All right, okay. Think of an escalator as well. All right, there's many processes that will what? Okay, an escalator can only go in one direction. All right, it can't go up anyway. All right, or there is one that goes up. Remember, there is when you can climb escalators downwards, you can climb them up, but normally they are dedicated. The one that goes down, the one that goes up. Okay, but then now someone could actually modify that what call this the escalator and say, okay, if one has a problem, we could use one to go down and go up. It's possible to do that. I'm not saying it's done. I'm saying it's possible to do it. All you could do is make sure that if once the motor goes down, it goes down for a while. Let's suppose the two escalators, one of them is broken, and you want to what you call this intermittently allow up and down. So you could actually program it to do that with what is called a forward reverse data. Forward or reverse data. The forward or reverse data means you can either go in the one direction or the other direction. Now you don't want a situation where your motor is given both commands at the same time. You can't tell a car to go forward and reverse at the same time. You can't put your car at gear 5 and then want to put in reverse at the same time. it will damage the motor. It will basically be a disaster. All right, so what we then do is we damage not the motor, the engine will be something else, will be scrapped immediately. So either you go in the one direction or you go in the other direction, and the one direction must first be stopped before we can reverse and go in the other direction. So what we need basically to have a stop, a start of what, what reverse starter, for instance, is basically two direction lines. Let's remember our direction line. Our direction line needs a what? Needs a, let's go there and choose either F1 or we just click there, and our direction line needs a, everything needs to be able to stop at some point. So I want this to be what? I want this, I've made a mistake here, I've chosen the wrong one. I should have said F2. Alright, but I want this to be a stop, so I'll change it. I'll come here and say I don't want that to be an X1. I'll come there and say okay, LTI, and there is a stop. Alright, remember in practice again, you said it might change. You might actually use the what? Use the normally open as a stop. Alright, so it will depend on the type of what, of stop pattern that we use. Alright, so bear that in mind. Now what I'll then do is I'll then go and say, alright, now we need to be able to start in that direction. We need to be able to start in a certain direction. But this is direction line, so we'll just say we need a start. So just come and say, okay, we need a start LT. Just say X1 is our start. Okay, so this here is our start. So the whole thing about direction line is it's a simple stop start. What call this? Okay, wrong choice. All right, it's a simple stop and start sequence. Now I will then say, what are we starting? We are starting a certain let's say motor or whatever. Whether it's for a remote control gate, whether it's for what you call this, an escalator going up or down. So direction line will still work even on the escalator. Okay. But I did want to say not an escalator. I wanted to say wait, an escalator. When it's moving in one direction, that particular direction at that instant will be a direction line. All right, let's go and say, and then a lift or cage. That will be also, if it's moving in a certain direction, you stop it. You can stop it and start it in that same direction. Let's say you are going up. So all the time, so you can stop at a certain floor, people get out, you continue in that direction. So we need a stop or start for that particular for a specific direction. It is just a direction line. So now we are going to say, let's have our motor, the motor that does the specific direction. So by the way, this has to be an output and it has to be Y0. So now what do we have? We simply have a stop start. What is missing here? We are missing there, because we are not going to hold the start pattern all the time. So we are missing basically the latch. All right, don't forget the latch. So we come and say, all right, then what do we do? We say a lot Y0 there, and there we have our latch. So once let's look at it. Let's simulate this part. Let's just go and say, all right, if I say put it online. Yes, I will deal with the problems later. If there's any problem, for now it's a simple sequence here. I've didn't debug it. Now you can see the stop is all right, by default closed. Now when I press my start, when I engage my start, which, oh by the way, it's also don't run yet. So let's run it. Yes, I want to run. Okay, it was on run, was it? Oh no, it was on stop. Yes, we didn't run it. So now we say start. All you do is engage set the start on, and obviously we are not going to keep our finger on the start button for as long as it runs. So we'll release and it will latch on. All right, that is our direction line. So this direction line, however, could be, let's suppose we are looking at the scenario, we are looking at interlocking here. My primary focus here is the interlocking, but that interlocking will automatically lead us to what? To the to understanding the forward and reverse. All right, but for now, what I want is to have a separate process with its own stop. So what I want to do is, let's go back to editing. We want to add a second process here. Insert a row. Right now on that there, what you want to do, we want to say, again, this one will have its own stop, LTI, and then we want it to be probably a different stop, so it's going to be X2, And then what we want to say, this is, okay, let's call that one stop 1 and this one called stop 2. This is stop 2. Alright, so now, meaning that there would have been stop 1. Not because we've got 2 different stops, so we've got 2 different processes. There we are, stop 1. Alright, now, so this will then be start 1 as well. We change that to start 1. Okay. Alright, now we come there, so therefore we need, so all we're doing, we're doing 2 different direction lines. So we are going to basically repeat what we did on top there. So all we do is say load this time, and you say x3, alright, and then you say this is our start 2, right? Then what we do, we say okay, we come and say we need to insert a row there, and come and say we are doing exactly what's on top there. So this is going to be another motor for the other direction. Oh, I want to load it y1, okay, and then we're going to say close that parallel line there and out y1. So what we have here, we've got 2 motors here, but if for whatever reason, okay, let's call this machine B, okay, that one there is, let's call it machine A. Excuse me, machine A. Now if we look at this, if for whatever reason we do not want these machines to run at the same time, we are then going to interlock them. All right, that is the whole idea of interlocking. All right, now what we then do is we come and say, when we want to do to say when machine A is running, machine B cannot run. When machine B is running, machine A cannot run. That is, the one is locking the other, and the other one that's likewise to the first one. So now what we call that, the two are they are working together, they are interlocked. All right, you have the one machine. You can have a condition where the other machine, when one machine is running, the other one is not. Like for instance, if I wanted machine A to not run when machine B is running, all I'll do is come and say, okay, machine B must come and interfere with our power line in a way that when it is energized, that line will break. That obviously means a closed what call this contact controlled by machine B. So we'll come there and say, okay, let's load machine B is called Y1, load a closed contact controlled by machine 1, which is Y1. All right, machine B, sorry, which is Y1. Did I say load? Is that an I or a 1? Let me just be sure. All right, yeah, that was an I. That's a 1. I think I put a 1 there. So if I do that, this is machine B closed in the rung of machine A. So therefore, if machine B is to to be energized, what it then means is that it will break that line. So it will be unable to do anything with machine A. So it will actually disable machine A. I don't know why my system is freezing. I can see that my picture is freezing all over the place. So I don't know. It's just me. So as long as you can see what I'm doing there, I can freeze forever. I don't mind. So now, what I'll then do is, I'll then say, let's check this now. All we want here is one machine to disable the other machine. When the one machine is running, the other machine cannot run. In this case here, when machine B is running, machine A cannot run. Okay, let's go there and say, let's simulate this. I won't worry about things. This is a simple program. I'll just load it. I won't worry about the error messages. Just accept whatever comes. Then all I want is to run this. Let me run this now. Now let's try and run machine A. Now, machine A, set on. Machine A is running perfectly. Why machine B is not running? Let's stop machine A. Let's stop machine A. Stop. what am I doing? I'm supposed to set it on. I'm supposed to energize that stop button. So now it is stopped. I can't hold this forever, so I set it back on, off. So I set it back on. So now that machine is stopped. Can I start machine B? Let's start machine B, and machine B runs perfectly. So there's the machine runs perfectly, and it will stay on there. But now let's try, because machine B is running now. Our rule was when machine B runs, machine A must not be able to run. Let's go and try to run machine A again. And machine A says, okay, we've energized the start, but because that part is broken, there's no way power will pass through here. So therefore, because, in case you don't notice this, because machine B there, that contact there is broken by virtue of machine B being on. So what happens is that we cannot have what? We cannot have power going through there. All right. So we cannot start machine A. Not until we what? Not until we come back and say, let's stop. Let's stop machine B. Once we stop machine B, we've gone back to, oh, by the way, it was already off. We need to energize it. Now, once we stop machine B, you can see what happened there. You can see that I wanted to set it off to take it back to its normal state. You can see that this is now ready now. Once machine B is not active, if machine B goes off, now you see that that contact there is back to being ready. Now we can come and say, okay, can we now start machine A again? Yes. So what we see here is that we can make one machine disable another machine. What happens now in this case, if we start machine B, machine A will automatically stop, because machine B runs independent of machine A, but machine A depends on machine B. So if we now say set on, you can see machine A automatically stops. The moment that one went on, that one stopped. All right. So this is how you've locked out one machine using another machine. So now this is the one machine locking the other one. Okay, this is the one machine locking the other one. What do we then do to? Okay, what am I doing? Destroying my circuit, but anyway, it's refusing to. Okay, let's just put back our out. I was trying to remove those lines that I think there. Let me just remove them with an eraser. All right. So load, we wanted to, or with our interlock here, load. No, we had an output in this case. Let's go back to where we were, because out, that was Y1, okay? And then this one here, we had the what? We had Y1 locking out, so it was a closed here. No. It was a closed here. You can use F2. It was a closed here from Y1. Y1, and that closed contact from Y1 was disabling Y0 if Y1 was running. All right. So now, if we do the same, if we now say right now we've got Y1 machine B locking out machine what? Machine A. What about if machine A says, I'm retaliating, bruh. If you lock me out, I lock you out. And machine A comes here and says, we place a contact from machine A there, a close contact LDI, and that is machine Y0. And if we place a contact controlled by machine A, now you can see when this energizes, obviously, when machine A energizes, obviously, I need this one. Let's first get out of here. I need the pen. If machine A energizes, now you can see that that contact there will be broken as well. All right, let's just try it out. So I'll remove the two my pens there. Now what I'll then do is I'll then say, let's try this one out. Now when we run let's debug it. Now we want to test it. It's our final structure. Okay, let me come out of debug and test this. Now you can see now when we run, if we decide, we can start whichever machine. There's no order. We can decide to start machine 2 first. In fact, let's do that. Let's start machine 2 first. All right. If we start machine 2 first, machine B, we set on. or I did not run, it's on stop mode. Okay, I'll leave it on start. All right, yes. Now if I start them, you can see that Y1 runs. Now can we, obviously I'll release my finger from the from the button there by setting it off, but you can see your machine is on. As long as the machine 1 is off, this is the previous scenario, you can see that machine B says you can't start. Let's try and say we are arrogant and we want to force it on, and it says no, I said you can't start. So even though we hit the start, as you can see our start is green there, it says no, you're not starting. Now we come and say okay, set it off. We see that the only way now is to stop this machine first and say set on there, breaking that, and then obviously now we are not going to keep our hand on there, so we're going to set it off again. Now can we start that other machine? Let's try. Set it on, and yes, there is our machine running. But if it's interlock, this is the interlock part now. They are both locking each other out. So between them now, this is an interlock, this is an electrical interlock. Actually, this is not even an electrical interlock. I won't want to say. If it was physically wired, I'll say this is an electrical interlock. But this is a soft interlock. This is a program interlock. Right? We don't have a physical interlock now. Okay? This is a program interlock. And then if you see now, if we try to start the other motor now, set on, it says machine O says you, machine A says you cannot, because machine A, by virtue of being energized, machine A came and broke. By virtue of being energized there, machine A came and said no, that line there is disabled. All right, so now this is the two of them. The two of them are what? If you look at these two, this is the interlock. This is the interlock. All right. If the one is on, the other one cannot run. If the other one is on, the first one cannot run. So this is the interlock. So the two machines are interlocked. All right. So that was the concept. I hope it was easy and fun to understand. You can do it with more machines. If you want two machines, for instance, to disable another machine, you basically use the same concept. All right. I could say, for argument's sake, let me just come and say, to help people understand more, let me just come and say, let me remove that clutter. Let's program again. Let's suppose I wanted to add a third machine. Let me say I wanted a third machine. A third machine, I would come there and say, okay, let's insert a row there. I want 2 rows because I know I'm going to need to interlock. Insert a row again there. Right, now let's suppose I come there and I say I want a third start, the LDI. What they do, LDI, a third stop, sorry. Let's say that is LDI X4. I just want to make the concept very clear, so I'm putting a third machine there. Let's call this stop 3, not stop 4, stop 3. It was X4, but it's stop 3. Now that then I want a start for that one as well. So I'm gonna say LD, sorry, and I'm gonna say X5. Okay, and then I'm gonna come and say that's a start 3. Okay, I should have gone for the comments first, and I come and say, let's say that's a start 3. All right, let's say now I come and say, let's go down a little, and then once we are here, we say, okay, here we want machine 3, which will be Y2. Let's say load, we want the contact Y2, and then that will be to interlock. We'll say that is our Y2 is actually machine 3. We are loading a component from machine C. Okay, and then now we come and say, okay, we right now all we want is to close the latch. Now we say out, and our machine is Y2. Right, so now then we can come and say, okay, we've got 3 machines now, and now we want to interlock them. Let's say our condition is, if machine if we can operate 2 machines. All right, we can operate 2 machines, and the third machine cannot run if the other 2 are working. let's say we can operate 2 machines at a time, and the third machine cannot run if the other 2 are working. That is tricky, right? So what will you say? So we have to interlock these machines. We have to interlock them. So we have to say, if machine A can run with machine B, okay, and then because I'm introducing this concept, let me not go for something that's sinister for now. Let me just say machine A and B cannot run together, okay. Machine C can run provided the other 2 machines are not running at all. What I want to say here is, because the other scenario is a little bit long, I think for someone introducing a concept, it might be a little bit of a sinister attack there. All right. So let's just rather say machine A and B cannot run together. Okay. And machine C, even worse, machine C cannot operate if any of the machines are running. All right. So machine C is interlocked by both of them. I think that's an easier thing to avoid our video being excessively long. What I'm going to do, we're going to come and say, okay, so when machine A is running, machine C cannot run. Let's go and say it's a close contact, obviously, from machine A. When machine B is running, machine C cannot run. So we come and say it's another close contact from machine machine B, right? This is machine B is Y1, right? Okay. So now what does it mean? As much as these 2 are interlocked, they are both locking out the other one. All right, they are both locking out that machine. So let's try and see if that works. I think this is an easier one to make our video. We want to avoid making our video unnecessarily long. So we come and say, okay, let's load this. Let's take this online, and then let's see. Machine A can run. Machine B can run if machine A is running. Already that was tested. This was the first part. Now I want to see if any of the machines is running. Let's suppose that's machine A running. Oh, I did not. It's on stop mode. So let's come and say it's on stop mode. So let's put it on run mode first. Then come and say now it's on run mode. There we see it's on run. Now we come and say let's start you again. Set on. You can see that machine is running. Now neither, because we said this one, you can see it comes and breaks. We already know what it will do to that one. That was our first part of the work. Now you can see it also disables what? Machine C. So machine C cannot run if that one is running. So set on, and machine C says no way, I am not running. Machine A is running. First stop machine A if you want me to run. So if you go and stop machine A, we already know that machine B could not run either. Remember that it's interlocked, so machine B could not run either. Alright, so machine B could not run either. So if you want the other ones to run, the other ones, any one of the other ones, you have to go and say stop this one first. Okay, and then come. Now you can see it's the 2 are ready. You can now come and say let me run this one, and you see machine C is running. So yes, of course we don't have, because we have latched, we will not need to keep this on. We don't need to hold our switch. All right, our push button down. So now, because none of them, let's start machine B now. You will see automatically machine C will stop, because we said if these 2 are running, machine B cannot run. All right, set off. All right, so now this is very nice. This is very interesting. We could also, just for people to understand the interlocking, we could also say, so machine C won't run again if you try, as long as this one is running. You can see that, okay, machine C is not running. So now, and you can see that, because you can see already, there is machine B blocking. The fact that it's not energized there means that that part cannot be cannot be started with a mere start. All right, it cannot be powered on with a mere start. All right, so we need to stop that one first. We could even make it more interesting. After all this, we can then say, okay, want to stop, so we set it on. After all this, we can say, okay, make it more interesting, and by the way, we need to set this off and set that off to take them back to normal positions. If we don't do that, it's like we're still holding the push button down. All right, now we could make this interesting. Okay, machine A and machine C cannot run if you did not what, if the machine, sorry, not machine A, machine C cannot run if any of the other machines are running. But if none of the machines are running and you start machine C, then it simply means that the other machines won't run until machine C is what? Is actually stopped. So actually interlocking it now. You can come and say, we want, yes, machine C won't start as long as you are running, gents. But if machine C does start, okay, it has a priority now. You will not start either. Alright, you will not start as long as machine C is running. So it simply implies a simple interlock where machine C comes here and says, I will be closed here for as long as I'm off. Alright, so it's a what? It's a normally closed. Alright, so this will be Y2. Machine C will come and say, I'll place a normally closed interlock there. Interlock because you locked me, and then I will place another one on that machine so that none of them can run as long as machine C. So machine C won't start if any of them are operating. But once machine C starts, they also cannot run. Alright, so you can come there and say, okay, let's put another closed one from machine C, which will be our Y2, normally closed from Y2. Now if machine C starts, we can just go and test that part because we don't want the video to be unnecessarily long. We can come and test that part and say, now if machine C starts, will any of the other ones start? And the answer is no. Let's go online first, then let's go on run mode, and then yes, we are going to run. Now if we start machine C, the other conditions have not changed. All it's done is add this part. If we start machine C, as you can see now, these contacts here are broken now. Okay, these normally closed contacts are broken now. So you cannot possibly start any of the other ones. You cannot possibly start any of the other ones because machine C says I said so. Alright, so you can't start because machine C says I said so. You cannot start. So there is what the concept of interlocking. I try to make it a bit of a long story so that people can get a picture of what this concept of interlocking is. When you do the practical part, you will see actually the mechanical interlock as well, because it is good practice, remember, to use them both. Now I would like to see if people liked what we had to share. If they did, please hit the like button there, and also please, if you haven't joined the family yet, join the family. Please say on the comment section where you are watching us from. And with that, I think our video has been long enough. So see you on the next run. All right, bye.